Hello everybody, my name is Muhammad Iman Zuhair bin Muhammad Edian. My matrix number is 01DKA23 of F2009. Today I will be explaining about vector and scalar. What is vector? Vector is a physical quantity that has both of magnitude and a direction. Geometrically, we can picture a vector as a directed line segment whose length is the magnitude of the vector and with an arrow indicating the direction. The direction of the vector is from its tail to its head. Continue on. What is scalar? Scalar is a physical quantity that is completely described by its magnitude. Example of scalar are volume, density, speed, energy, mass, and time. Other quantities such as force and velocity have both magnitude and direction are called vectors. So, what is the difference between vector and scalar? A scalar quantity are different from vector quantity. In terms of direction, scalar don't have direction, whereas a vector has due to this feature. The scalar quantity can be said to represented in one dimension, whereas a vector quantity can be multidimensional. From the table given in the next page, let us learn more difference between scalar and the difference between scalar quantity and vector quantity. Scalar quantity has an only magnitude but not direction, while vector quantity has both magnitude and direction. Every scalar quantity is one-dimensional. Vector quantity can be 1D, 2D, or 3D. Any change in scalar quantity is the reflection of change in magnitude. Any change in vector quantity can reflect either change in direction or change in magnitude or changes in both. Scalar quantity cannot be resolved as it has exactly same value regardless of direction. Vector can be resolved in any direction using sine or cosine of the adjacent angle. Any mathematical operation carried out among two or more scalar quantities will provide a scalar only. However, if a scalar is operated with a vector, then the result will be a vector. The result of mathematical operation between two or more vectors may give either scalar or vector dot product of two vectors gives only scalar, while cross product or summation or subtraction result in a vector. For example of scalar quantity, length, mass, energy, density, etc. Example of vector quantity, displacement, velocity, acceleration, force. Lastly, application of vector and scalar. Vector and scalar are necessity and widely used in our daily life. It is used in many aspects which involve physics in life, such as engineering, architecture, geography, and navigation. It also has been used to visualize displacement, velocity, acceleration, projectile motion, military usage, vector in gaming, roller coaster, crosswind, and many more. In our presentation, we'll use vector and scalar to find the angle of a popular building and area of its surface.
Assalamualaikum, my name is Putra Nasim bin Alias. My matrix number is 01DKA23F2017. So today I'm going to talk about formula and application. Scalar dot products of vectors. The scalar product or dot product of two vectors A equals to A1x plus A2y plus A3z and B equal to B1x plus B2y plus B3z is defined as follows. In components, A dot B equals to A1 B1 plus A2 B2 plus A3 B3. In geometrically, A dot B equals to magnitude A multiplied by magnitude B multiplied by cos theta. Example, calculate the angle between vectors. A equal to 2i plus 5k minus 4k and B equal to negative 4i plus 5k plus k. So using the component formula, we should do A dot B equal to 5 negative 4 dot negative 4 5 1 equal to 2 multiply negative 4 plus 5 multiply 5 plus negative 4 multiply 1. And using calculator, you should get 13. So next, to find the magnitude of A and magnitude of B, you should use the formula square root x square plus y square plus z square. So A magnitude equal to square root 2 square plus 5 square plus negative 4 square. Using the calculator, you should get square root 45. For magnitude B, square root negative 4 square plus 5 square plus 1 square. Using the calculator, you should get square root 42. To find the angle, you should use the formula of cos theta equal to A dot B divided A magnitude multiply B magnitude. So cos theta equal to 30 divided by 45 square root multiplies 42 square root equal to 0.29990, and then use the cos inverse 0.29, and using the calculator you should get 72.6 degrees. So next is scalar cross product of vector. Given two linearly independent vector A and B, the cross product A multiplied by B is a vector that's perpendicular orthogonal to both A and B and thus normal to the plane containing them. The cross product is defined by the formula A multiplied by B equal to magnitude A multiplied by magnitude B multiplied by sin theta. We want to find the degree of inclination of this building using the scalar dot product of vector. So given A equal to 4i plus 60j plus 25k, B equal to 1i plus 9j plus 36k. So using the formula, A dot B equal A1b1 plus A2b2 plus A3b3. A dot B equal to 4 times 1 plus 16 times 9 plus 25 times 36. So using the calculator, you should get 1048. Next, to find magnitude A and magnitude B. To find magnitude A and magnitude B, we should use the formula square root x square plus y square plus z square. So A magnitude equal to square root 4 square plus 60 square plus 25 square. Using the calculator, you should get square root 897. B magnitude equal to square root 1 square plus 9 square plus 36 square, and using calculator, you should get square root 1378. Next is to find the angles. To find the angles, we should use the formula cos theta equal to A dot B divided by A magnitude times B magnitude. So cos theta equal to 1048 divided by square root 897 times square root 1378. So using the calculator, you should get cos theta equal to 0.9426. After that, you need to inverse the cos, so you get the theta. So using the calculator, theta equal to cos inverse 0.9426 equal to 19.5 degrees.
Hi, my name is Muhammad Arizmi Batman. My metric number is 01DKA23F2002. I will be doing a conclusion for vector and scalar. So, vector and scalar are utilized in day-to-day life to assist in the localization of people, places, and things. A quantity that possesses both a magnitude and a direction is known as a vector, while scalar is a quantity that possess magnitude only. We use both vector and scalar quantities daily in our life without us knowing what we do. Some technology apply vectors and scalars in order to make it happen. Without it, our life will be somehow lacking, because vector and scalar have contributed a lot in making our life better. That's all from me. Thank you.